Amazing conversation so far, and thank you all so much to all of our fantastic speakers. Now up next, we'll welcome DFINITY's founder and chief scientist Dominic Williams, here to shed some light on insights on tokenomics and the latest of the service nervous system.
Hello, LA Blockchain Week. I'm great to be here. Today I'm going to give you a quick introduction to the internet computer, and follow that with a talk on its tokenomics and the forthcoming service nervous system functionality, which is going to be incredibly important to dapp developers in Web3, because it's going to allow them to completely decentralize their dapps and services and raise money from the community. There's already about 50 projects ready to go when this functionality activates in January. By then, there could be even more. So we're going to quickly look at the internet computer blockchain and what it's all about. And then we're going to get on to some of the tokenomics and the service nervous system stuff and the decentralization auctions that many of you who are dapp developers are probably very interested in. So first of all, who am I? My name's Dominic Williams. If you haven't come across me before, I'm the president and chief scientist of the DFINITY Foundation. DFINITY is a not-for-profit organization based in Zurich. The foundation was actually formed, I think, October 2016 in Zug, moved to Zurich the next year. And we built out this absolutely extraordinary team over the years. We've got research centers in Zurich, where I am today, San Francisco, Palo Alto, a lot of remote teams. We're about 200 strong. We employ many of the world's leading cryptographers, brilliant computer scientists, and senior engineers. You may already be aware, we're by far the biggest R&D operation in blockchain, and we're working away for several years before the internet computer launched on the 10th of May this year. And of course, we continue working. The Internet Computer Association is a new not-for-profit organization that's been formed to provide support to people in the ecosystem. Developers, governments, investors, backing new projects, people running node machines, researchers at universities, and so on. And I think you may well have already heard about the DFINITY Foundation. You probably won't have heard much about the Internet Computer Association yet. You can find the DFINITY Foundation at definity.org, and you can find the Internet Computer Association at internetcomputer.org. And that's also where you'll find a fantastic dashboard that gives you real-time stats on the internet computer. We at the DFINITY Foundation are united by a mission, and that is to enable what we call blockchain singularity. So blockchain singularity is the migration of all of humanity's information systems and services onto blockchain. And this is made possible by a complete rethink of blockchain, a lot of powerful new cryptography and computer science that provides people with a genuine world computer, i.e. a blockchain that runs incredibly fast at web speed with enormous efficiency, and which can scale its capacity for processing smart contract computations and smart contract data infinitely, and which also enables smart contracts to serve interactive web directly to users. And we believe smart contracts provide just a much superior platform for building everything than traditional IT. Smart contracts run on a public network. They're tamper-proof, don't need firewalls. They're unstoppable. They're kind of software and systems at the same time, right? So you can compose new systems from existing smart contracts, and much the same way you build software from components. And one smart contract can be a system unit in multiple larger systems at once. And of course, smart contracts can be autonomous, so you can use tokenization. And for all of these reasons, we believe that in the end, all of humanity's systems and services, or at least the vast majority over time, will be rebuilt on public blockchains like the internet computer. And in the process, of course, completely reimagined, because blockchain brings new capabilities. Yeah, and that's why today's DeFi ecosystem on Ethereum looks very different to traditional finance. It's because it's built with smart contracts. The internet computer, has been scaling out. It's already got vast computational power. I think it's already processed almost 300 million blocks in the short time it's been running, which gives you an idea of the step change it provides from traditional blockchain. I think it's at about 25 blocks a second at the moment, but we expect that to get into the hundreds of blocks a second and thousands of blocks a second and so on. It's infinitely scalable. I think at the moment, it's got about 12,500. Just look at these stats: 12,500 things called canister smart contracts, which are either oftentimes just complete dapps, right? Standalone dapps, sometimes just smart contract units. And there's 300, almost 350 terabytes of on-chain persistent memory. Okay, so very quickly, today blockchain is just way too complicated for the users of Web3 dapps. So when you interact today with a dapp, or at least what's called a dapp, if it's not running on the internet computer, there's 100% certainty that you're really interacting with a website on, either on a server or more likely a corporate cloud service like Amazon Web Services. And, that website really, is a trusted intermediary. You have to trust that it's patching you through to smart contracts on the back end. And it's vulnerable to being switched off by Amazon if they decide they don't like blockchain applications in the same way they decided they didn't like Parler, right, last year. And that, all of the significant data storage and processing takes place on Amazon Web Services. So even if you buy an NFT, an Ethereum NFT, you're interacting with the website on the corporate cloud, and on the back end, that's just going to take a fingerprint of whatever content you bought and store it on Ethereum. The actual bytes of the NFT live on the corporate cloud. Even your access to this thing is mediated by the corporate cloud. If you're interacting with an Ethereum dapp, or a dapp on an Ethereum killer family blockchain, you're downloading like a wallet into your browser that enables you to send transactions through the website to the blockchain. That wallet comes from the Chrome Web Store. You're trusting that nobody naughty at Chrome has changed the code to steal the tokens. And again, it's another censorship pressure point. In 2018, Google actually banned the MetaMask wallet, Ethereum's MetaMask wallet for a while. So there are a lot of problems with the way it's all architected today. And on the one hand, users can never really be sure they're interacting with smart contracts because they're interacting with a website in the corporate cloud. It's a security vulnerability. On the other hand, there's always the risk that the corporate cloud will censor dapps, or that the people creating these dapps self-censor. So Uniswap recently just delisted half its tokens, and the smart contracts involved in Uniswap, the Uniswap exchange on Ethereum, are pretty decentralized. They're controlled by governance tokens, but the developers of Uniswap operated a cloud service, centralized cloud website, people to interact with it, and so they became transitively liable, right, for the smart contracts, and it got a bit scary for them, so they actually just delisted half the tokens. Users obviously get a bit of a, apart from the fact they have to trust that the cloud website's patching them through to real smart contracts and it hasn't been hacked. Users also, it's a bit of a clunky experience. You have to download this with Ethereum, for example, MetaMask wallet, and sort of manually configure transactions. You have to basically have Ether in your wallet before you can even interact with these dapps. Okay. So what's the internet computer? Without further ado, the internet computer is a super advanced new blockchain, rethinks blockchain architecture from the ground up. It's designed to provide the world with a world computer. It's actually created by a protocol called ICP, Internet Computer Protocol, and that's from where the ICP token gets its name. And the Internet Computer makes it possible for smart contract software to be used to build anything, Web3 dapps, SocialFi, GameFi, DeFi, NFTs, even traditional websites and enterprise systems, and all without any cloud. And that's the really important point. Okay, so something else that's really interesting about the Internet Computer is that it runs from a completely sovereign physical network. So this is interesting because actually today, most of these proof of stake networks you hear about are running from the cloud. So if you go to, the technical documentation of, Polkadot, Cardano, Avalanche, Solana, Flow blockchain, any of these guys, right? Even these proof of stake blockchains, they'll instruct you how to create a node on Amazon Web Services. Now, it makes it very easy for people to spin up nodes in the blockchain network. The trouble is they're all, a lot of them are running on the cloud. And, if Amazon Web Services decided that they didn't want to support blockchain anymore, not only could they obviously switch off all these dapps, they could also say we just switch off these entire blockchains. If they were really malicious, I think this is unlikely. If they were really malicious, they could even steal all the validator keys, right, from these proof of stake nodes and just take the blockchain over. I think that's unlikely. They just switch it off. So we, at DFINITY, blockchain maximalists, we think this is the wrong way forward. And so the Internet Computer was designed to run on a sovereign network, and it runs on a network of what we call node machines. Node machines have a sort of standardized hardware spec, and they're run by independent owner operators. And if these node machines don't have the right spec, there's a danger that they sort of fall out of sync, essentially, statistically, with other nodes, and they get slashed. So the architecture goes like this. You've got, dapps and smart contracts that are hosted on the Internet Computer blockchain. And in 10 years from now, we think there'll be billions of those. Inside the Internet Computer blockchain network, there are actually things called subnet blockchains. And each additional subnet blockchain increases the capacity of the overall, the Internet Computer blockchain that they create, and it scales completely seamlessly. So, the subnets are actually completely transparent to the dapps and smart contracts running on the Internet Computer, and that's because the subnet blockchains work together as a single blockchain using some very, very clever cryptography. You might have heard about it. It's called chain key cryptography. And it was, developed here at the DFINITY Foundation. So, these subnet blockchains are comprised from nodes run by independent owner operators. Nodes are combined with a view to maximizing decentralization. So, it looks at this hierarchy of node operator, data center, geography, jurisdiction. We think in 10 years, there'll be millions of these node machines, and thousands of data centers will be used to host them. So the Internet Computer blockchain hosts an advanced evolution of smart contracts, and they're called canister smart contracts. And the advantage of these things is they're fast and they scale. They're called canisters because actually they implement something called a software actor model, which enables them to run in parallel, which you might intuitively see is essential really to true scaling. And each canister comprises a bundle of WebAssembly bytecode. WebAssembly is a new virtual machine standard. The inventor of WebAssembly actually works at the DFINITY Foundation. It's a bundle of WebAssembly bytecode and persistent memory pages. And the bytecode in a canister can only access, it has exclusive access to these persistent memory pages. So what's really, really cool about the Internet Computer is, and this I think sort of gives a clue to its disruptive potential, is that developers build new Web3 dApps just by uploading, canister smart contracts to the Internet Computer. And these canister smart contracts can serve interactive web content directly to end users. And This means that no corporate cloud services are needed. So you get rid of all those choke points and problems with censorship, whether it's other people censoring you or you having to self-censor because you're worried about the regulatory aspects of your tokenization. So there are a number of kind of differences. One of them is that we just talked about canisters serve web directly to users. So smart contracts are basically now, basically servicing HTTP requests, which gives you an idea of how far blockchain's coming along technologically. Another one is they pay for their own computation. So this is called the reverse gas model. So one of the problems I mentioned with traditional, Web3, which involves the corporate cloud and MetaMask and everything, is people want to grow their dApps into millions of users, but in order for somebody to use one of these dApps, they have to pre-install MetaMask in their browser and then somehow purchase cryptocurrency, for example, buy Ether and put it in the MetaMask wallet before they can actually do anything meaningful and interact with the blockchain at all. So that's obviously a huge problem with respect to upfront friction, and it creates a big barrier to entry for users. So on the internet computer, the smart contracts actually pay for their own computation in the mode, like a bit like a Tesla car's charged up with electricity and consumes the electricity when it drives around. Smart contracts on the internet computer are charged up with these things called cycles, and they burn through them when they perform computation. And they're very efficient, which is one of the reasons that this is possible. And this means that users can interact with dApps and services created using canister smart contracts on the internet computer without having tokens. So the internet computer, as you might have guessed, has pretty incredible speed. It finalizes an update transaction which changes smart contract state in about 2 seconds. It's very consistent. And that, to give you an idea, is 8 times faster than Solana, which is a very centralized, thing, but it's widely lauded as being fast. Internet computers using very sophisticated real distributed cryptography, and it's doing it in 2 seconds. And if a transaction does not mutate state, it can be processed in milliseconds. And actually, when when smart contracts are serving, for example, web content, that's happening through these query transactions, which are certifying the state, which the browser transparently is cryptographically verifying. It's very interesting, and that's happening obviously milliseconds. That's a prerequisite for having a blockchain that enables smart contracts to serve web. So that's not all it does. The on-chain cost of computation is now approaching that of traditional IT, and the reason for this is obviously it's very efficient, but also that it can scale its capacity with demand. So if the demand for on-chain smart contract computation and data increases, the network grows, and this means the cost of smart contract computation and data stays constant. That compares with a traditional blockchain where there's a fixed capacity, and there's effectively a kind of market, an auction, which allows different people wanting to access it to pay more to get it, and that just bids the price up. So to give you an idea, a gigabyte of smart contract data on the internet computer will cost you about $5 a year, paid for in these cycles, right, which is the equivalent of gas on Ethereum. And sometimes you can specify some parameters with respect to how your smart contracts run. In some cases, it will be higher, but also there should be upgrades to the network available next year that bring it right down. By contrast, I mean, I looked today actually, and the cost of 1 gigabyte of smart contract data on Ethereum has gone past $500 million. I mean, it's mind-blowing. And if you were wondering why dApps on traditional blockchains are really, websites running on the corporate cloud that just make a few calls to the to a blockchain on the back end, this is why. If you want to, for example, mint an NFT on Ethereum, there's just no way you can store the bytes of the NFT on Ethereum. I mean, gosh, if the NFT was a video clip, say, right, I don't know, say UEFA, made an NFT out of some amazing clip of Lionel Messi scoring a goal, and it was a gigabyte of video data, right? Storing that NFT, that video NFT, on Ethereum would cost you $500 million, which is clearly probably very much, even in these crazy times, very much more than the NFTs were. So that's why, when you create an NFT, it's just the bytes are kept on the corporate cloud, and just a fingerprint of those bytes is stored on, say, Ethereum or Solana, or whatever it is. The difference with the internet computer is that you can actually, it's so much more efficient and the costs are so much lower. You can actually store the bytes of the NFT on the internet computer blockchain itself. We had a kind of interesting ride since we launched. It seems that not everyone's too pleased to see this sort of very disruptive new blockchain technology appear. There's not been that much press. We had a lot of sort of fun going off on social media and things like that. It's been a bumpy ride, but it turns out that blockchain engineers and entrepreneurs can read between the lines, and they've been adopting the internet computer in droves. So I haven't stayed absolutely abreast of it, but a couple of weeks ago plus, there were already more than 1,000 developers building on the internet computer. I think we've given out grants to more than 100, and we're still just giving out grants all the time. And a lot of these new projects are doing things you couldn't possibly do on any other blockchain. Like there's one, I always talk about this one because I know the guys, but called OpenChat, which is actually running a chat service from the blockchain. There's no cloud involved. And what's really interesting is that it's an example of an emerging new sector called SocialFi, right, which blends social media functionality with DeFi functionality, and there's also going to be GameFi and many other things. And so eventually you're going to be able to send your chat service account is going to be it's going to be like a crypto wallet too. So you'll be able to send Bitcoin and ICP and things like that in chat messages. It's going to be really interesting. So as I just mentioned, I just front ran myself. The internet computer is pioneering new trends, and we see SocialFi, the metaverse, and GameFi as being incredibly important amongst these. So you may have heard that you can now compile Unity applications down to WebAssembly and run them inside the browser. Well, as I mentioned, internet computer smart contracts are also WebAssembly, and it allows for some very interesting integrations. You can have internet computer smart contracts serve Unity front ends compiled to WebAssembly, and that can interact with the smart contract. So you can, provide people with amazing 3D worlds using that functionality. And where it gets interesting is how you can integrate with other things. So, obviously a sort of 3D world created that way would enable people to interact with tokens, cryptocurrencies, that kind of thing. But what if those, what if that, game, some GameFi application that integrates through some 3D game universe with crypto wants to add chat? Well, they can integrate OpenChat, right? And that would enable people to start chatting and sending tokens with messages and things like that. I think that's how the metaverse is going to evolve. It's going to be a sort of collision of a lot of different kinds of system. And SocialFi blends social media with DeFi. GameFi blends game functionality with DeFi. The metaverse I just described is when those two things come together, right? You're in a 3D world, and in that 3D world, you've also got social functionality with DeFi. So, here we go. Yeah. So something else with this, I mentioned that SocialFi blends social media functionality with DeFi functionality. One of the big meta changes, though, is going to be that, the users are going to become both the owners and teams of these services. And so what that means is, I think social media is going to grow by airdropping governance tokens to users, and creating token incentive frameworks so they help with things like moderation. GameFi is going to just transform gaming. All of a sudden there's going to be, real play to earn. And if you want to do this, you've got to run in a totally decentralized way, because unless you run as almost like an extension of the blockchain, there's just no way you're going to be able to provide this kind of functionality. But it's going to be absolutely transformative. It's through SocialFi, through GameFi, and through their collision, the metaverse, that blockchain is going to bring in billions of users. This is really where the big future opportunity lies. I'm pleased to say, there's a lot of very talented people already building out the sort of metaverse functionality on the internet computer. And what's cool is that it runs 100% from the internet computer. There's no cloud and there's no Facebook. So we're going to get to this. If you truly decentralize, and we'll talk about how, and you have the community fund your project, the internet computer is going to be able to self-fund its ecosystem. And this is what a lot of those, projects building on the internet computer now are planning for. And nobody should underestimate the power of decentralized finance. And a lot of this stuff's activating in a couple of months on the internet computer. So I'm going to give you some steps here, okay? I want to give you some concrete steps for pursuing the sort of true blockchain maximalist path. And step one is, realizing that corporate cloud services are kryptonite for Web3 dapps and services, and that if you want to escape that kryptonite and gain the full power that blockchain can give to you, you're going to build on the internet computer without any use for use corporate cloud. You're going to build on the blockchain only. Be a genuine Web3 app. And this is a difficult one because we're in a very frothy market today, and people have lost track of the facts. I've been recently running a survey and talking to some crypto journalists, and one of the things I like to ask is, the first one I ask is, what percentage of dapps running on the internet computer are running using corporate cloud? And they give some maybe 10%. It's 100%, right, almost, because the only blockchain that can serve whose smart contracts can serve interactive web content is the internet computer. So if you're using another blockchain, inevitably you're going to be building with using the corporate cloud, and this introduces so many problems. Even if the markets don't know it now. And another thing people just aren't aware of is, like I said, how much do you think a gigabyte of smart contract storage costs on Ethereum? The answers are always things like, $10, $50. You tell them $500 million and for a gigabyte, and they just look at you like you're mad. They just can't grasp that really, dapps today aren't really dapps, they're blockchain applications. It's not, and unless you're actually serving the interactive web content from the blockchain, then of course it's not really Web 3.0. And the reason that's bad is that you're going to, as I'm going to explain in a moment, you lose the chance to use advanced tokenization. So step one is just build your service using the internet computer blockchain, and stay well clear of corporate cloud services. It's kryptonite. Step two is hand control of whatever you built to a service nervous system. Now, a service nervous system is basically a super advanced DAO, or decentralized autonomous organization. And this functionality actually activates in January. And if you built a SocialFi or GameFi service, or something that's better described as a metaverse service, or just plain old DeFi or some other kind of blockchain application on the internet computer. In January, you're going to be able to press a button, and when you do that, the internet computer blockchain will automatically create a new service nervous system, DAO, for you, and it will assign control of all the smart contracts in your dappa service to the DAO. It basically takes over, and thereafter it's running under the control of the community. Step 3 is to, I mean, you don't have to do this. Now the service nervous system's in control. Step 3 is the service nervous system will run what's known as a decentralization auction. And this raises funds directly into the SNS itself, where it's obviously controlled by the community. So the difference between an ICO and a decentralization auction is that with an ICO, some group of developers or a company, creates some tokens and sells them to the public and receives the funds. With a decentralization auction, you create a DApp service, press this button, a new service nervous system is created, and control of all the smart contracts involved is assigned to this new service nervous system, DAO, and it now runs under the control of the community with thousands of anonymous participants, voting on proposals through these things called voting neurons, right, which they can create by staking, and it then creates a ledger of 1 billion governance tokens, and begins by auctioning off a whole bunch of these. So in this example here, 400 million of these governance tokens are auctioned off in a single clearing price auction to people over the internet, and the participants in that auction then control the service nervous system and the funds raised through the auction. Typically, then it'll grant governance tokens to the original developers, and that could be just a team of developers, could be a team of developers and an entrepreneur, could be a team of developers and entrepreneur and some investors. Can be any arrangement. This is a great ecosystem for venture capitalists to participate in. And typically when for both participants in the decentralization auction and the founding team, they receive these governance tokens ready staked in the governance system mostly, right? So the governance tokens are already playing their role, and then you typically save some share for users, right? Because as we discussed, users in the future are going to be both owners and both the owners of Web3 services and the team that runs them, right? So in this example, 400 million of the 1 billion governance tokens are sold in the decentralization auction. The funds raised are kept inside the service nervous system DAO itself, under the control of the community, for things like developer grants and so on. 250 million are given to the founding team, and then 350 million are reserved for users. And you can imagine with something like OpenChat that random airdrops happen all the time. So if you happen to be online, some randomization engine inside OpenChat will just ping you and say, hey, do this captcha to prove you're not a bot. And if you can successfully pass the captcha, it's like, oh, here's 3 governance tokens. Some random time in a few days does it again. Hey, do this captcha to prove you're not a bot. And if you're lucky enough to be online at the time, it may say airdrop you 10 governance tokens. And through this, you can basically make users the owners of your SocialFi, GameFi, Metaverse, and any other dappa service you create. Make them the owners. They automatically become the team because they start advocating for the service and bringing new users in. And you can also create advanced tokenization frameworks to get them involved in things like moderation. So this is the crucial bit. This is why you've got to care about decentralization. Once you are running under the control of a service nervous system, the community is in control. In fact, this decentralized brain, this DAO, this service nervous system is in control. And effectively, it has become an extension of the blockchain. It's an autonomous extension of the blockchain. And what you've done is essentially created a microeconomy within the overall blockchain's macroeconomy, right? Which is incredibly powerful because blockchains can do tokenization. It's easy to see why. Bitcoin is decentralized, right? And that's why it was able to succeed. Nobody could turn it off. People tried, governments tried in the early days. It's truly decentralized, and people eventually came to accept that truly decentralized systems can, incorporate tokenization. But if you, went and created MyCoin on an Amazon Web Services instance, right? Even today, if you create MyCoin on an Amazon Web Services instance, various regulators and police forces and so on will actually come and take you away. You can't do it, right? It has to be decentralized. So when you totally, and this is, helps you understand why that if there's huge advantages in totally decentralizing your DApp, because now, you can employ advanced tokenization. So, I mean, we just talked about a very simple one, and that is airdropping governance tokens to users so that they become the owners of the service, and then also naturally become part of the team advocating for it, and later on get involved in things like content moderation through other token incentive frameworks. You just absolutely need to decentralize to do this, and this is where the huge opportunity lies. And if you want to get involved in SocialFi and GameFi and the metaverse on blockchain, you need to be serious about decentralization and eschew the corporate cloud at all costs. Just go the fully decentralized route. And as people are going to see shortly, you're going to be able to raise far more funds from the decentralized community when you're running in this form than you would otherwise be able to raise through sort of centralized, more traditional methods, like foundation grants and VC, albeit they can also be helpful. And the DFINITY Foundation, by the way, gives out lots of grants, as I mentioned. Okay, so I think we've covered basically what the internet computer is. It's kind of groundbreaking in its functionality. It's got a huge team behind it. It's the biggest, backed by the biggest R&D team in blockchain. That has really created some astounding advances on the science, and we've covered why and how you should totally decentralize and do this in order to raise funds from the decentralized community, but also to run as an extension of the blockchain that allows you to incorporate advanced tokenization that will allow you to win. Because we've got to keep our eyes on bringing in the first billion users to blockchain. The internet computer is also doing some other stuff. I mentioned it's powered by this thing called chain key cryptography earlier. Chain key cryptography is an incredible thing. It basically allows the blockchain to have what's called a chain key. It's a bit like a public key. And the blockchain as a whole can create signatures that validate against that chain key. And internally, this is actually absolutely crucial to how the internet computer scales, because as it creates new subnet blockchains, they can all communicate with each other without seeing each other's state. They just can see that they've got a chain key that's signed by a master chain key, the one true public key of the blockchain, the internet computer blockchain, and that their interactions validate against it, and that tells them the state is real and that the interactions are real. Now, chain key cryptography is a long time in coming. If you go to DFINITY.org and go to how it works and poke around in places like the non-interactive DKG section, you'll find some of the low-level cryptography involved. It's an absolute beast. But it's incredibly important for blockchain. Now, the internet computer is all running with chain key cryptography, and we're extending its application. It turns out that the internet computer can also create transactions on the other blockchains like Bitcoin. So we're directly integrating with Bitcoin, and smart contracts on the internet computer are going to get their own Bitcoin addresses. And that means that smart contracts on the internet computer can send and receive Bitcoin on the Bitcoin blockchain. This is very different to wrapping, bridges, sidechains, all that kind of stuff. Smart contracts on the internet computer will actually have their own Bitcoin addresses, which is a pretty seismic thing. And that means a smart contract on the internet computer can send and receive Bitcoin. If you know the address of a smart contract on the internet computer, you can just send it Bitcoin from your wallet. And likewise, a smart contract on the internet computer can send other smart contracts Bitcoin and send smart Bitcoin to any arbitrary Bitcoin address, such as yours or my wallet. So this is incredible because for the first time, Bitcoin's going to get its own sort of native smart contracts in a way, and it's going to provide for the creation of native Bitcoin DeFi. So much in the same way that smart contracts in Ethereum can store and move Ether, these internet computer smart contracts can store and move Bitcoin. So that's going to be fantastic for Bitcoin, and we're sort of super looking forward to seeing what people build when this stuff is activated early next year. In addition to that, of course, it's going to bring $1.5 trillion of liquidity straight onto the internet computer blockchain, and I think we can all agree that that could be interesting, especially when you begin to combine Bitcoin liquidity with SocialFi and GameFi. I mean, you could have like a metaverse within which Bitcoin's being moved around. And there are ways of, when Bitcoin moves, it moves on the Bitcoin blockchain, but you can also move it within a smart contract locally and basically move Bitcoin inside a metaverse environment in 2 seconds. So this could be incredibly exciting. And I think it illustrates the power of, hardcore cryptography. And it helps explain why we spent so many years in R&D and have such a huge team of, very famous cryptographers oftentimes, and computer science researchers and engineers. So finally, people have asked about this a lot, and we also plan to integrate with Ethereum using the same technology, and smart contracts on the internet computer will be able to call into Ethereum smart contracts and vice versa, but that'll take a little bit longer, not least because the Ethereum blockchain is in flux and its protocols being updated. Okay, I think I've finished in time. Thank you for listening. If you made it this far, check out the internet computer, check out canister smart contracts, new languages like Motoko. Get involved with building the future on blockchain. Thanks a lot. Thank you so much for listening.